Hi, this is Jaydeep Sai, and the topic which I have selected for this TikTok video is Yesterday, Today, and Tomorrow 50 Years of Software Engineering. Let's discuss the introduction of the topic. Just 50 years ago, software engineering emerged as a field unto itself, legitimatized as a branch of science and technology, joining the pantheon of professions devoted to engineering. So just 50 years ago, software engineering emerged as a field unto itself, legitimatized a branch of science and technology, joining a pantheon of professions developed to engineering. So the different professions which were devoted to engineering were combined to make the software in engineering. Many professions which were related to engineering joined software engineering to separate itself as a science and technology. Today, software eats our world. So we can see everywhere we go, we use the software. So the software eats our world. So the software is dominating now. Our daily lives seem built on the languages of programmers. We furnish clothes and feed ourselves by going online, often with help from recommendation algorithms. Our cars run on code as much as fuel. So the software engineering has a lot of impact on our daily lives. So from daily from starting to at the night time, we are using software knowingly or unknowingly. So our daily life seems built on languages of the programmers. So our daily lives seems like they are built by the languages of the programmers. We furnish clothes. So the clothes which we are using, which we are washing, is also made through a software. Feed ourselves by going online. So when we are planning to go online, it's also because of the software engineering, which is done to by using the recommendation algorithms. We are recommended to purchase the shopping now. Our online cars run on code as much as fuel. And chances are you are reading this on a device whose life blood is software. So now you are hearing this audio or video. So it is also due to this lifeblood of software. Now the finest minds in software, including the pioneer who invented software engineering, gather as this half-century milestone and look into the past and future of revolutionary instructions that are software. This analysis is also chronicled in the Computer Science Society's IEEE Software magazine, describing the speed of software's journey and daunting frontiers ahead for software developers. So, about the history of the software were also being published in the IEEE Software magazine, describing the speed of the software's journey, how it was in the past and how it has developed exponentially, and how it's now and how it would be in the upcoming future. It is always described in the IEEE Software magazine. So, software controlling the social activities of the world. Software's evolution is nothing short of breathtaking, growing from a small discipline in 1968 with a restricted number of experts into a mass industry, writes Manfred Bore, a professor at Technische University Mannheim and the foundation president of Centrum Digitalizer Rango. Even for a software engineering, it is amazing to see how our field has developed over the past 50 years. Broy says, in yesterday, today, and tomorrow, 50 years of software engineering. So it looks like yesterday, today, and tomorrow. The 50 years were passed in that way, where rapid development of software has occurred. So we can see compare our past 50 years from now. Then we can compare that there are a lot of changes made in our daily lives due to the interaction of the software in our daily activities. So the software now made our lives better, but it also made our lives lazier, and we are now in the very lot of troubles because of the technology's improvement and its devastating approaches on the humans. When dealing with the first programs, when writing the first software in the 50s and even in the 60s, no one could have expected the role of software plays today. Cyber physical systems are everywhere and are operated by everyone. Software has become part of physical reality. It changes and enhances physical reality. We have to keep in mind that in 1968, most of software was running on mainframes, not on a network or not directly connected to the processes of the real world, and was therefore quite separated from those. Nowadays, software is tightly coupled with physical processes and controls a lot of technical and social activities of the world, he says. Indeed, untold fortunes are won and lost even day as Silicon Valley gambles and the next big thing in software development. So when the first program, when writing the first software in the 50s and even in the 60s, no one could have expected the role software plays today. Cyber physical systems are developed everywhere. So we can see the cyber physical systems which are developed everywhere, operated by everyone. So these cyber physical systems were developed everywhere and now they are operated by everyone because software is the main role of the software development is to make it simpler for everyone. So that's why it can be operated by everyone. Software has become part of physical reality. It changes and enhances physical reality. We have to keep in mind that in 1968, most of software was running on mainframes, not on a network and not directly connected to the processes of the real world, and was therefore quite separated from those. Nowadays, software is tightly coupled with physical processes and controls a lot of technical and social activities of the world, he says. Someone told. Indeed, untold fortunes are won and lost every day as Silicon Valley gambles on the next big thing in software development. So, Garganton has been software's growth that Broy suggests that new languages are needed. It is amazing that important areas of software engineering have not developed further as it necessary considering the quick evolution of technology and applications. One example is programming languages that do not reflect the needs of today's programming of cyber physical systems. Our programming languages are not good for handling real time interaction and distribution. Coding is error prone, not sufficiently abstract, and still done too close to machine level or at least at the OS level. mixing application logic with low-level technical systems, he replied. Someone replied. So, Gargantian has been software growth that Roy suggests that new languages are needed. It is amazing that important areas of software engineering have not developed further as it necessary considering the quick evolution of technology and applications. One example is programming languages that do not reflect the needs of today's programming of cyber physical systems. Our programming languages are not no good for handling real-time interaction and distribution. Coding is error-prone, not sufficiently abstract, and still too close to machine level or at least to the OS level, mixing application logic with two-level technical systems. Software engineering inventor remembers no schools for it even existed. The early days of software evoke a wilderness frontier, says Margaret Hamilton, the computer science pioneer who coined software engineering while working for the Apollo spacecraft. This robot exploration system is defined with the function map, FMAP, run robot, and the type map, which is TMAP, robot. Fmaps represent the dynamic world of actions doing by capturing functional, temporal, and priority characteristics. So the early days of software evoke a wilderness frontier, says Margaret Hamilton, the computer science pioneer who coined software engineering. While working for Apollo spacecraft, this robot exploration system is defined with the function map FMAP, function robots, and type map, TMAP robot. FMAPs represent the dynamic world of applications doing by capturing function, temporal, and priority characteristics. It was not quite the 60s, she writes. No school existed for learning how to build software. You were on your own courses if any, were concerned only with becoming familiar with a set of available commands to tell the computer what to do, sometimes provided by the computer's manufacturer. So it is quite not quite the 60s, she writes. No school existed for learning how to build software. You were on your own. Courses, if any, were concerned only with becoming familiar with set of available commands to tell the computer what to do, sometimes provided by the computer's manufacturer. It was difficult to understand why this and only this seemed to matter. Just knowing a set of English words would not demonstrate one's ability to write a good novel. Experience with programming language needed on a particular project was in great demand. So experience in the programming language needed on particular project was in great demand. Little did we know what were doing then would become knowing years later as software engineering. When we were in trenches building flight software for Apollo missions, Hamilton writes in What the Errors Tell Us. Hamilton details and dramatic account of historic Apollo 11 mission. When the software discovers a hardware problem and then compensates for it, the story's ending is magnificent. So little did we know what we're doing then would become knowing years later as software engineer. When we were in trenches building flight software for application missions, Hamilton writes what the errors tell us. Hamilton details an dramatic account of the historic Apollo 11 mission when software discovers a hardware problem and then compensates for it. The story's ending is magnificent. Agile thus mainstream. Long before there were waterfall and agile methods to developing software, there was something of a wild west. Originally, computer software was written in an ad hoc manner. The programmers often had no formal training but great domain knowledge and aptitude, most commonly used using large scale non-wet networking machines and lacking a common set of principles and practices. This process was really more akin to a cottage industry than an engineering discipline. Right, Rasina Oda of University of Auckland, Norsame Saleh of International Islamic University, Malaysia, and John Grandi of Monash University. Closely behind Agile and DevOps on design of as software evolved the past 50 years. So did IT developments, which in the early 1960s developed played a supporting role in businesses to reduce costs and make operations more efficient, writes Eric Dorenberg of ThoughtWorks in the path of DevOps. So in the 1960s to 1970s, businesses supporting roles. The businesses supporting roles were made in software developments, and in the 1980 collaboration was made, and in the 1990 technology-driven differentiation was made, and in the technology is the business now. Software development has led the way, and now the DevOps and design ops movements are hitting the mainstream. In my opinion, IT in businesses is now entirely a team activity. While there is as ever as a need for experts with deep technological knowledge, we must focus our attention on how we get people from all disciplines working together effectively, he says. The path of the DevOps. What is software engineering is the question. And software engineering is a branch of computer science that creates practical, cost effective solutions to computing and information processing problems, preferentially by applying scientific knowledge, developing software systems in the service of mankind. The profession needs rigorous software engineering education based on enduring principles, and the field must reach the increasing diversity of developer community and diverse paths the developer takes into profession. They write in half a century of software engineering education, CMU, exemplary vulnerability prevention practices. Their research found that firms could better use a software security group, which is SSG, for vulnerability prevention. The researchers prepared a chart below that showed the percentage of 109 firms that use the 30 software security practices countering the injection of vulnerabilities. Two practices are used to prevent the injection of implementation bugs. The methodologies are used on average by 18% of firms. 28 practices are used to prevent the injection of design flaws. These practices are used on average 28% of time. Overall, the 30 practices are used 27% of time, with more firms using design flaws prevention practices that implementation bug prevention practices. I thank the faculty and college for providing me this opportunity to speak on the topic. Thank you.